How does the distance formula relate to a metric space? Imagine you're trying to find the shortest path between 2 points on a map. You might use a ruler or a GPS to measure that distance. In math, we have a way to do this for any set of points, and it's called the distance formula. This formula is a specific example of something called a metric, which is just a fancy word for a rule that tells us how far apart 2 points are. When we put all these points together with their distances, we get what is called a metric space. Think of a metric space as a universe of points where we have a consistent way to measure how far apart they are, following some rules. Now let's look at the distance formula in coordinate geometry. Suppose you have 2 points in the plane with coordinates written as x1, y1, and x2, y2. The distance between these points is calculated using the formula, the square root of x2, x1, 2 plus y2, y1, 2. This comes from the Pythagorean theorem, which helps us find the length of the hypotenuse in a right triangle. It's like measuring the straight line distance between 2 locations on a map. This formula isn't just a random way to find distances. It actually defines a metric, which means it follows certain rules. First, the distance from any point to itself is 0. Second, the distance between 2 different points is always positive. Third, the distance from point A to point B is the same as from B to A. Fourth, the triangle inequality holds, meaning the direct distance from point A to point C is always less than or equal to going from A to B and then B to C. These rules ensure the distances make sense and behave predictably. When you use the distance formula on points in the plane, you are working within a metric space where the set is all the points in the plane, and the metric is the Euclidean distance defined by the formula. This means the formula isn't just a way to measure lengths. It's a specific example of a broader idea in mathematics called a metric space. In more advanced geometry, you can define other metrics on the same set, but the Euclidean distance from the distance formula is the most familiar and easiest to understand. So every time you calculate the distance between 2 points using the formula, you are applying the concept of a metric space. This helps us understand how distances work in different spaces and make sure they follow consistent rules. This foundation is essential for studying more complex shapes, angles, triangles, circles, and polygons, where understanding how distances behave is key to solving problems and understanding the geometry around us.